Okay, hello everyone. Thank you for being here. So today our goal is to go through binary search. Last couple of days we have talked about linear search, implementation of linear search. Today we'll continue our discussion on binary search. At the same time, you will be introduced with a new algorithmic technique, very effective, very useful, and easy to implement competitively. One new technique which is called divide and conquer approach. You will be introduced with that technique too. So without wasting any more time, let's start with binary search. So linear search, you know that you need to sequentially search, compare every element of the array with your searching number. And what is the drawback of linear search? What is the drawback?
Too long, it takes too much time.
It depends on the length of the array or number of elements of the array. So linear time, big of n, proportional to n, where n is the number of elements in that array. Is it on? Yeah. But in case of dictionary, do you follow the same approach? That is linear search. Do you search starting from the first word or first page and go through towards that particular page? So what approach you take in case of dictionary search?
Kind of like that dividing.
Yeah, hit in the middle. You hit in the middle. Suppose this is your dictionary or array containing 15 elements, and since we are we need the middle element, we need to track the mid index, right? So how we can track the mid index? How do you know where the middle index resides? How do you know? For this array.
Divide by 2.
Yeah, divide by 2. To whom?
The size of the array.
Size of the array, or you may think the 0 plus 14 divided by 2. Right? So 0 plus 14 divided by 2. So you need the low index or left index, whatever you name it, and the high index or right index, whatever you name it. So low plus high divided by 2. That would be your mid index. This way you can find out where the middle element resides in that array. So okay, so you have calculated, and 7 is the mid index. 7 is the mid index. So which one is the mid element of the array? The mid element. 53, right? 7 is the mid index, but 53 is the middle element of the array. Okay. Now what you will do? You will compare the middle element with the searching number. Your searching number is 33. So what does that mean? Your middle element is 53 and your searching number is 33. What does that mean?
It means it's lower than, you're searching lower than 50.
Lower than 53. That means you don't need to look into this part, because it is the middle element is already larger than your searching number. So just discard this part, right? So you discard this part. But programmatically, how you can discard this part? And think recursive way. So we will call the same function, we'll change the parameter only. So we just need to discard this part. How we can do that? We can move high to this index. So we can move high to mid -1, because we already have compared with the middle element. So we can move high to mid -1. So that means we'll consider only this part of the array. and discard the rest. Clear? So first we find out the middle element, then compare the middle element with the searching number. If the middle element is greater than the searching number, we'll move high index to mid -1. Okay, so high equals to mid -1. So again, we'll call the same function and pass this part. Means the same array with this low index and this high index. So we'll not change the array actually. The same whole array would be passed, only we'll change the index so that he can, the program will focus only this part of the array. So this is low, this is high, and repeat the same process. So what would be the next step?
Find the middle element.
Yeah, again, find the middle element. How we can find the middle element? Again, low plus high divide by 2. That's why you mentioned size divide by 2. Since we are sending the same array, size divide by 2 will not work. We are changing the indices, low indices, high indices. So this is mid, current mid. Again, compare your current middle element, that is 25, with your searching number 33. What does that mean? So middle element is smaller than your searching number. That means which part you need to look into? Towards this part, right? So you will discard this part. Now, programmatically, how you can discard that part? Mid +1. Change the low to mid +1 because you have already looked into mid. You can move to mid. The program will work properly, but it's not efficient because we have already checked the mid element. So move low to mid +1. Okay. Again, repeat the same process. Calculate the mid. So new mid would be this one. And compare the mid element, that is 43 is larger than 33. So what does that mean? You will discard which part? Right side. So how we can discard that? Change high to mid -1. Mid -1. Again, so now low and high both are pointing to index 4. Calculate again the middle element. So middle would be 4. And the middle element is 33 equals to your searching number. That means you have found it. Here, the steps that we are taking. So the first step is calculate, find the middle element. Then compare the middle element with the searching number. So there can be 3 cases. So step 1 would be find the mid index. Then suppose the mid element is array or mid. This is your mid element of the array. Now you need to compare it with your searching number. And when you compare between these two entities, how many cases will be there? If you compare X versus Y, what are the cases can be there? Either X equals to Y, or X greater than Y, or X less than Y, right? These 3 cases can be there. So similarly, we are comparing middle element of the array with searching number. So there will be 3 cases. So case 1. When both are same, By the way, please take your note because there is an assignment called scribe notes. So just take your notes, handwritten notes or digital notes, and you have to just upload that, submit that note, and you will get 5 points. And be careful. I'll go through that note, and if I see that you did some sloppy jobs, then I have to deduct some points. So just take your notes. That will help you in both, in many ways. So case 1 is when they are equal. So obviously, what does that mean when they are equal? You have found it. So it's the best case. You have found it. So found. Case 2, when array mid greater than searching number. That means this one. In this example, array mid means 53. 53 is greater than your searching number 33. So what you need to do if that is the case? When your mid of the mid element of the array is greater than your searching number, what you need to do? Yeah, get rid of this. How we can do that?
Set the index of high to
Mid minus 1, right? So if that is the case, just high equals to mid minus 1. And case 3, that is array mid is searching number. That is this case. This one. When middle element of the array, that is 25, is smaller than your searching number. So what you need to do? You need to discard which part? This left part. How we can do that? By moving low to plus 1, right? So low would be mid plus 1. That's all. So you have understood how to perform binary search, right? Very easy way. Is there any questions so far? Any doubts? Okay, so I have uploaded one code on binary search. So please download it. If you look into the code, then you can see there are 2 binary search functions are written here. One is iterative way to implement binary search. Another one is recursive way to implement binary search. And but the main gist of the binary search is this part. So we need to do this. We need to go through this one. So if we talk about the iterative way, binary search underscore iterative at line 11, I think. You may look into that. So you can see first step 1, that is to calculate mid. So step 1 is to calculate mid. Is it clear to you, this line? Is it what is expected? Because I have told you what is mid. Mid equals to low plus mid equals to low plus high divided by 2. it is this, it is same. If you solve it, it would be the same equation. Why I have used that? To avoid overflow. If low and high both are very large number, their addition would be another very large number, and it might create overflow because every integer maximum it can hold maybe 2 to the 32 something. So if your number is more than that, it will create overflow. So to avoid that overflow, here high is added with low, but here high minus low, which is comparatively smaller term, divide by 2 is added with low. So we are adding a comparatively smaller term with low compared to this one. And if you solve that one, it is saying mid equals to low plus high minus low divided by 2. So it means low plus high divided by 2 minus low divided by 2. Low minus low by 2, that is nothing but low divided by 2 plus high divided by 2. So same. Both are same actually. But this way of representation will avoid that overflow. So in your job interview, it would be better if you can provide this answer. But if you can't remember, or if you can't digest that part, then you can go with this one. Mid equals to low plus high divided by 2. But both are, either one is fine. Both are correct. Clear so far? So first stage is calculate calculate mid. That is this one. Find the mid index. And don't be confused with the mid index and mid element of the array. This is mid index. And mid element of the array is array mid. This is the mid element of the array. So searching number will be compared with mid element of the array. So check one. Case one is the check if search number is present at mid. So this is our case one. This is this one, case one. So you just need to compare mid element of the array with searching number. If that is the case, then return the mid index. Clear? Case one. Now case two. If searching number is smaller, or in other words, the middle element of the array is greater than the searching number. Same as this one. What you need to do? Just modify high. High will become mid minus 1, right? And the case 3, that is under else condition, low will become mid plus 1. That is this one. Low will become mid plus 1. Case 3 means when your searching number is greater than your middle element of the array. So you need to modify the low, value of low index. Clear so far? So it is the iterative way to implement binary search. Similarly, you can do it recursively. Same. First, you need to calculate the mid. After getting the mid, you will compare the middle element of the array with the searching number. The first one is same when both are same. Case 2 when the middle element of the array is greater than searching number. That is this one. Middle element of the array is greater than searching number. Now we'll call recursive function. So the same function binary search underscore recursive will call itself and pass those parameters, 4 parameters. First, name of the array, no change, the whole array will be passed, you may think. Low index. Low index will not be changed, only high index will be changed. Next one is high index. So high will be changed to mid minus 1. So we have modified high. And the search number will be as it is, no change. This part is clear to you. How we can call recursive function and by changing parameters. And this is case 2. Case 3 would be the same. Only low index will be changed here. Low would be mid plus 1. Rest would be same. Here. So it's very easy to implement binary search. So my suggestion would be first try to understand this code, and in your spare time, try to implement this code by yourself from the scratch. Then you can understand every bits of the code. Okay. Now, what is the time complexity of binary search? What is the time complexity for linear search? In the worst case, n, right? Big of n. So we also need to find out what is the time complexity for binary search. And in your exam, you obviously will get one question from here. So what is the time complexity of binary search? Let's calculate, derive that. So see, so initially this was our whole problem, right? After one iteration, we calculate the mid element, mid index, find the mid index and compare the mid element with our searching number and focus only one half of the array, right? So we find out, and next iteration will focus only this part. So half of the problem will be discarded, right? So initially the problem size is n. Or in this case, you may think the problem size is 15. There are 15 elements. And in the next iteration, how many elements are there? 7, right? How many elements? From 15, it becomes 7. In the next iteration, how many elements are there? 3. So you may think it divides, every time it divides by almost half. So the initial problem is n. In the next iteration, it will become n by 2. In the next iteration, it will become n by 4. Every time it will be half. It will become n by 8, and so on up to there is a single element, right? This one. There is single element. So in our example, that was the case, right? Clear so far? So what is n by 2? It is nothing but n by 2 to the power 1. It is n by 2 square. It is n by 2 to the power 3. Now what it is saying, after one iteration, try to understand this one. After one iteration, the initial problem of size n becomes n by 2 to the power 1 after one iteration. So this is after one iteration. Now after two iteration, this is two iteration. After two iteration, the problem of size n becomes n by 2 square, right? And after three iteration, the problem of size n becomes n by 2 to the power 3. Now let's assume after k iteration, we don't know what is k. After k iteration, n becomes 1. We assume that. After k iteration, the problem of size n becomes a problem of size 1. So we can write it 1 equals to n divided by 2 to the power k. Got it so far? Clear? So 1 equals to n. So let's write it here, n by 2 to the power k equals to 1. Or n equals to 2 to the power k. If we take log n equals to log 2 to the power k. It means log k log 2 and base is 2. Why base is 2? Because we divide the problem into half. Every time we divide the problem into half. That's why the base is 2. So what is log 2? Base 2. Log base 2. What is the value of this one? 1. So what is the value of k?
Okay.
Log n. So here we assume that after k iteration, the problem of size n will become 1. And what is the value of k? Log n. That means after log n step, the problem of size n will become 1. So how many steps it will require to complete binary search? Log n step. So the time complexity is big O of log n, and the base is 2, because every time the problem will become half of the initial size. Clear so far? So the time complexity of binary search is log n. You have understood how to derive, and this is a very important way. This strategy of in this same strategy we will derive many other. We'll calculate different time complexity for different algorithms. This is a very standard way to derive that. So please keep that in your mind. It's not difficult. Clear so far? Any questions? So for linear search, the time complexity was big O of n, and now in case of binary search, we have got big O of log n, and log n is much smaller than n. N is much larger than log n. So it's much improvement in terms of time complexity. So you may expect one question or more than one question from this part in your midterm as well as in your final exam. So please pay attention here. At the same time, did you take the notes? So in the same logic, we can write a recurrence relation like T of n. T of n is the time take to perform binary search when the array has n elements, means the initial array on the whole array, when you perform the binary search on the whole array. So it becomes T of n by 2 plus k, means what I'm trying to say, this is our initial array, right? Now we our goal was to perform binary search on that array. What thing we did, first we calculate mid, and to calculate mid equals to low plus high divided by 2. So it's a constant time. It's constant, so we will ignore those constant. So calculate mid, compare mid element with the searching number, and focus only one half of the array, right? So just Tn is the to perform binary search on the whole array, equals to, we can write perform binary search on this half of the array plus some constant time. Constant time for calculating mid, constant time to compare the mid element with the searching number, constant time to move the high index to mid minus 1. So some constant time. It doesn't depend on any variable. So Tn equals to Tn by 2 plus some constant k. So this is the recurrence relation. I'll not go into much details right away. After one class, we'll discuss it more. Just for now, keep that in your mind. The recurrence relation for binary search is this one. Tn equals to Tn by 2. That means the problem of size n will become problem of size n by 2 plus some constant time. So if you notice in case of binary search, we divide every time we are dividing the initial problem into half, right? So the strategy that is being used by binary search is divide and conquer. Divide and conquer approach or algorithm. So every time we are dividing the initial problem into half. So we'll learn more about divide and conquer approach. And at the same time, we will apply this divide and conquer approach to solve different other kinds of problems too. So one problem that is binary search based on divide and conquer approach we have studied so far. So let's dig deeper into divide and conquer. But before going into that details, binary search, okay, it's very fast. It gives you order of log n time complexity. But there is one condition before applying binary search. What is that condition? Yeah, array must be sorted. If array is not sorted, then what you can do?
Sort the array.
Okay, you either go for linear search, or you can sort the array, then go for binary search, right? So time taken, so what would be the total time? Time spent for sorting the array plus time for binary search. And that would be obviously more than linear search time. Linear search is big of n, sorting algorithm will take n log n plus log n. So it would be larger. But if you think that initially if you sort the array, and suppose if you need to perform searching million times. So that would be which route you will take. You need to perform searching million times. Then and the initial array is unsorted. So which strategy you will take? You will go for linear search, or first you will sort that array, then you will perform binary search million times. Which route you will take?
Binary one.
Second one, because you are searching million times. So initially, let's sort it. Then perform binary search million times. It will save your time, right? Okay. Before going into that details, binary search in your job interview, they might slightly change your this problem like this way. Let's briefly discuss that. Suppose your array is like this. So this is a sorted array, and you have understood binary search. Now the question is slightly, I can change it, like you need to search 2. The searching number is 2. What will be the answer? In this case, your searching number is 2. What would be the answer?
1 index. The answer should be 1 index.
Yeah, answer should be index, means position. So 2 is present here, 2 is also present it here, 2 is also present it here, 2 is also present it here. Which one will be your answer?
The first of the
Anyone. Anyone is true. But if the question is such that if you need to find out the first occurrence of 2, you need to find out the first occurrence of 2. How you can do that? You can do that, but it will not be efficient. You can apply binary search. Think how you can apply binary search to find the answer.
We will have to add more conditions. So if the left or right one is similar to the, like, if the middle term is 2, let's say, and if the left is also 2, then maybe, I'm not sure.
Yeah, just think what you can do. Hit the middle like binary search, and if you find out 2, don't stop there. Don't stop, because you need to find out the first occurrence. So again, search for the left half and repeat the process. Or same question can be asked like this way: last occurrence of a particular number. Right? So first occurrence, last occurrence. So this way, the question can be changed slightly, but you can still apply binary search. Obviously, you can apply linear search, but it will be time consuming. But you can apply binary search to solve this. So first, think. I'm letting you to think about that. How you can find out the first occurrence of a particular searching number, last occurrence of a searching number. Or even you may think, how many 2s are there? So last occurrence minus first occurrence plus 1 or something, right? How many 2s are there? So last occurrence is this one, first occurrence is this one. You may subtract that. So same binary algorithm can be used to solve this kind of problem. So in your job interview, they will not ask you apply binary search. You have to come up with your answer. Got the point? Okay, let's move on to divide and conquer. So binary search means we need a sorted array. So to set the platform, we need some sorting algorithm, right? We need to learn some sorting algorithm so that we can apply binary search. Means we need to putting the world in order. Sorting means we have to put everything in order. So how we can do that? But yeah. So what is the problem? Input is an array with n elements, and it is not in order, and you have to make it in order, either in ascending order or descending order. So you have you know what is sorting, right? So this is the sorting problem. Now, how we can do it efficiently? That's the obviously we need correct solution. At the same time, we need efficient solutions. So how we can do it efficiently, this sorting. So I'm not going into much details. In your data structure course, have you studied sorting techniques before? What are the sorting techniques you have learned? Quick sort, merge sort, and bubble sort, selection sort, insertion sort, heap sort. Okay, so bubble sort, insertion sort, selection sort. These are 3 basic sorting algorithms which are very easy to implement. When some algorithm is easy to implement, means less overhead. When it is difficult to implement, means more overhead. So they are easy to implement, means less overhead, but their time complexity is not good. So their time, they will take big of n square time in the worst case. Whatever I am saying, the time complexity in the worst case. What is n? N is the number of elements in that array. So it will take quadratic time complexity, order of n square. Clear so far? So can we do better than order of n square? Because why? Because order of n square sorting is infeasible when n is more than 100,000. So when n is very large number, these algorithms are infeasible. Although they are correct, but they are infeasible when n is very large number. What's the point so far? Okay, so we need better approach, more efficient approach. Let me share one incident, true incident. Now, in 2007, I think, the then president of United States of America, Barack Obama, he visited the headquarters of Google, maybe in California or somewhere else. And the CEO of Google, Eric, asked Barack Obama in an interview there that you have large number of large integers are there, many integers are there, which sorting techniques you want to use to sort them. So you have a very large, you may consider an array of very large size. So he asked Barack Obama that which algorithm you want to use to sort them. So Barack Obama replied that bubble sort is not the right way to move forward. He knew that part, that bubble sort is not the right way to move forward for a large size of array. So let's move on to discuss what are the better approaches available till today. So here we'd like to introduce divide and conquer approach to break the quadratic barrier. Quadratic barrier means order of n square. We need something better than order of n square. So the strategy that we'll take is divide and conquer approach. So divide means, as in case of binary search, what we did, we divide the problem into smaller sub-problems. So in your real life, suppose you have 5 or 10 homeworks due tonight. Let's assume 10 homeworks which are due tonight. What you will do? You'll be tensed. Other than that, what you will do?
Figure out which ones are the hard ones, which ones are the easy ones, and kind of
Okay, then
kind of take them one by one, which ones you feel.
yeah, one by one. Tackle one by one. That means in our real life, we know the strategy. When you have a large problem, you divide the problem into smaller sub-problems of different size and tackle one at a time. So we'll do the same thing. Tackle one at a time means what? Solve one at a time. So first we'll divide the problem into smaller sub-problems. And then finally, tackle each sub-problem, means solve each problem, which will eventually give you the solution for the whole problem. Like first you will solve one homework, then you will solve second homework, then third homework. Eventually you will complete the all 10 homeworks. Clear? So same divide and conquer. That means it's nothing new. We all apply it in our real life. Or you may think, pizza. This is your pizza. Okay? Large pizza. And the pizza boy did not use the pizza cutter. Okay? So this is your initial pizza, and the pizza boy did not use pizza cutter to cut it into smaller pieces. What you will do? What you will do? It would be very difficult to eat, right? You have to hold everything like this. It would be very difficult, not efficient way to eat the pizza, right? So what the pizza boy will do using pizza cutter? Did he cut the pizza like this way? No, right? So how he will use pizza the cutter to cut this pizza? So what? How first do this, right? Then do this, then this, then this. Up to when?
When there is a feasible size.
Right. When there is a feasible size that you can hold it like this way, right? So you will divide up to a certain point. It's not that indefinite time you will divide. So you will divide. So initially this was your problem. Now you divide into half, till you have this feasible size of chunk that you can hold it on your 3 fingers. So this is division. So this is the divide part. Now what you need to do? Conquer, means solve. What is the solution here? Eating, right? So first you will eat this chunk, then you will eat this chunk, then you will eat this chunk, and finally you will eat the whole pizza. Clear so far? What is divide? What is conquer? So divide means you will divide the problem into smaller sub-problems, and there should be some limitation. Until this point, you will divide. After division, you will start solve each sub-problem and conquer their solution. So divide the problem into disjoint parts. It is important. Disjoint. Here you can see this part and this part, there is no overlap. This part, there is no overlap. It is disjoint. If it is not disjoint, you cannot solve it in parallel. We'll talk about Fibonacci series using recursive function call. And then you will see there will be some sub-problems. Same strategy will be applied. The problem will be divided into some smaller problems, but the sub-problems will not be disjoint. There will be overlap. And we'll discuss the issue associated with that. But keep that in your mind. The sub-problems should be disjoint. There should not be any overlap. So first thing is divide the problem into disjoint sub-problems. Then solve each sub-problem independently. That's why you need to solve each sub-problem independently. If there is an overlap, you cannot solve it independently. So it should be disjoint. So solve it independently, finally combine solutions efficiently. So these are 3 steps in case of divide and conquer. So first divide the problem into smaller sub-problems, disjoint sub-problems, then solve each sub-problem independently and combine the solutions. That's all. Clear? So what we can do? So let me introduce you with a new sorting technique called MergeSort, based on this approach, that is divide and conquer approach. Any questions so far? So first would be divide. So since it is a sorting problem, you will have an array of n integers. Okay. So you will divide the array into 2 equal parts. So divide the problem into 2 sub-problems of size n by 2. Then separately solve. So suppose this is your initial array. This is your initial array. So first thing is divide into 2 halves, left and right half. And the next step would be solve each half independently and combine the result. And combine means merge. That's why it is called merge. This combination is combine. You are combining the result. Combining the result of left half with right half. It is called merging. You are merging the solution of left half with the right half. So got the point? So if this is your array, you will divide it into half, left half, right half. Solve the left half and right half independently, combine their result, merge their result. That's the concept. high level concept. Clear so far? So two things are there. First, division and also merging the solution. Let's assume so first we'll talk about the merging procedure. So let's assume you have solution for left half, solution for right half. Now you need to merge them. Clear? Okay. So the merging procedure or combining the result, how we can do that? So given two sorted arrays A and B, why sorted? Because we already have the solution. Let's assume you already have the solution. Now you need to merge those solution into one solution. So given two sorted arrays A and B, combine them into a sorted array C. Okay, that will be the merging procedure. So let's assume this is array A, this is array B. This is array A, this is array B. You need to merge them into a single array. This is also a programming question in your job, they might ask you. Suppose there are two sorted arrays. You need to merge them into a single sorted array. How we can do that? Forget about programming. Just think of this example. This is sorted array, this is sorted array. What would be the first step?
Compare the lowest numbers and then two squared ways, whichever one's the lowest goes first.
Right. So first step would be these are sorted, these are sorted. So first you will compare head of those two arrays. So compare 32 with 21. So 21 is smaller than 32. So 21 will move to your resulting array. So this is your resulting array, 21 moved here. Now compare which two numbers?
The second element of the second array and the first element.
Yeah, so there will be an index. You need to move, modify, update that index. So compare 32 and 55. And which one is 32 is smaller? So 31, 2 will move to your resulting array. Same, next, compare 74 and 55. 55 is smaller, so 55 will move to resulting array. Next, compare 64 and 74. 64 smaller, 64 move to resulting array. Now what will happen?
We just take the array.
Now this array is empty. So if that one array is empty, just copy this part because it's already sorted, right? So just copy 74, 89 here. Clear? So this is the merging procedure. So when you have two sorted arrays or two solutions, how we can merge them into one solution? That is called merging procedure. Don't be confused with MergeSort and merging procedure. Merging procedure is one part of MergeSort. In your exam, if I ask you how much time it will take to merge for merging, it would be different than your MergeSort. Don't be confused with merging and MergeSort. Merging is just one part of MergeSort. Clear so far? So what is merging? What is the merging procedure? Combining both the solutions. Combining solutions. Okay? So this is merging two sorted array. Now let's look into the MergeSort, the whole procedure of sorting. So far you are on track, right? Do I proceed? Okay. So this is your original sequence, which is unsorted. And you need to apply MergeSort to get the sorted sequence. So what is the first step? Division. Divide the problem into smaller half. So you will divide the problem into two subproblems. This is one subproblem, this is another subproblem. Do I proceed? Do I divide it again? Yes. Do I divide it again? Just think of pizza. How many times he used pizza cutter? Until you have a feasible size. And what would be the feasible size here? Array with single element. Because array with single element is already sorted. That's the best thing. If one array has a single element, it is already sorted. That means you don't need to solve anything. So this is array with two elements. So further you need to divide it. So this is the last stage of division. Every array has single element. So you don't need to divide it further. Stop it. So division process is done up to this point. Now, what will be the answer? This is already sorted. This is already sorted. This is already, everyone is already sorted. So every array with single element is already sorted. Now what we need to do? We need to merge them. So this is a solution. This is another solution. Merge them into a solution of size 2. These are two solutions. They are already sorted. Merge them into. So the same merging procedure, right? So this is already sorted. This is already sorted. You use merging function to merge them. Same thing. Merge them. Merge, merge. Did you get the up to this point? Same thing. This is already sorted. This is already sorted. Merge them. The strategy that we already discussed. Here, this is already sorted. This is already sorted. We have already discussed how to merge them, right? So this is already sorted. This is already sorted. Use the same strategy to merge them. Same thing. This is already sorted. This is already sorted. Merge them. Same. This is already sorted. This is already sorted. Merge these two into a single array. Did you get it? So first we divide the problem. Problem of size n. Divide, divide, divide until you have problem of size 1. When the problem is of size 1, that means it is already sorted. So these are individual solutions, already sorted. Now merge them, merge, 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 and repeat the process. So this is the whole MergeSort procedure. So you can see that merging, this is the merging procedure is applicable here. So merging is just a part of MergeSort. Like division. Division is one part of MergeSort. Now dig deeper into merging. Merging two sorted arrays, or how we can merge two solutions into one single solution. How much time it will take. So given two sorted arrays A and B, so this is array A, this is array B, and you have merged them into a single sorted array C. So what are the steps? But if we write the algorithm, what are the steps would be there? First, if either one is empty, what will happen? If either A or B is empty, what you will do?
Copy them exactly in the same order.
Yeah, copy the elements of the other array, just copy. So if A is empty, copy B into C. If B is empty, copy A into C. Very easy. Otherwise, compare the head element of both A and B. And which one would be smaller, we'll go to the resulting array. And repeat the process until all elements of A and B have been moved to your resulting array. So these are the steps that you need to follow. Is it clear? So obviously you need to you need 3 indices I, J, K, because you need to track every element of each of every array. So there are A and B array will be merged to C. So there will be 3 indices I, J, K. And you will compare, like you need one loop. Inside that loop, so M is the size of array A. Let's assume N is the size of array B. So what is the size of C, array C? M plus N, right? If the size of array A is M, size of array B is N, you are merging A and B. So the size of C would be M plus N. So the loop will run K less than equals to less than M plus N. K will start from 0 to M plus N minus 1. So 0 to M plus N minus 1. So inside that loop, what you need to check? First, you need to check whether any one array is empty, right? If one array is empty, you just need to copy elements of the other array, right? So when J equals to N, what does that mean? When J equals to N,
The index is the same size.
that means B is empty. When J will become N, that means B is empty. Right? You have traversed all elements already. So B is empty, no more elements left in array B. So when J equals to N means B is empty. So if B is empty, so copy every element of A to C, right? Did you get this point? And in case of I equals to M, when I will become M? I will become M when A is already empty, means there is no more element left. So if A is empty, so copy every element of B to C. Is it clear to everyone? Otherwise, if whoever will be, otherwise you need to compare the head element of every array, head element of A as well as head element of B, and which one will be smaller will go to your resulting array. So compare AI with BJ. If AI is smaller, then AI will go to your resulting array. If BJ is smaller, then BJ will go to your resulting array. Okay. So this way you can implement merging procedure, not the merge sort. Now let's talk about merge sort, the merge sort function. So in case of merge sort, you need to check whether the array contains only a single element. If the array contains single element like this one, the base case. So you will divide until the array will have a single element. So if the array will have single element, means it is already sorted. Otherwise, if right minus left greater than 1, means there are more than one element in your array. So first thing, you need to find the mid position, mid index, and divide the whole problem into two halves, left and right. So you divide the problem into two halves recursively call that. And finally, you will merge them. So it will give you left subarray, right subarray. Finally, we will merge the solution of left subarray and right subarray. That's all. So calculate the mid like this. First calculate the mid, then call the merge sort on the left half, merge sort on the right half recursively. And finally, do the merging. Merge the solutions of left half and the right half. So the next question would be, how much time the merging procedure will take? The merging procedure, this one, just think of this example. I'm not talking about the merge sort, the merging of two solutions. This is one solution, this is another solution. How much time it will take to merge the whole solution? Both solutions. What is the time it will take?
N plus 1.
you may also look into this loop. How many times this loop will run? M plus n times, right? So let's assume your initial problem is n. It divides into n1, n2. Okay. So array of this array has size n1. This array is of size n2. So how many? What would be the total time it will take? You need to go through every element. So it would be n1 plus n2, which is nothing but n. So the time it will take is proportional to n or linear. Why linear? Because you need to traverse every element of this array plus every element of this array. So the total time it will take is linear. It depends on the length of the array. If the length of the array is n, so it will be proportional to n. So in your exam, if I ask you what is the time, how much time it will take for merging? How much time it will take for merging? So answer would be order of n. And you may expect one question from here. Don't be confused with MergeSort. MergeSort will take n log n, but only merging procedure will take big of n. Only merging. Clear? Now, let's try to understand how much time the whole MergeSort will take. Merging will take order of n, I have understood. Now we need to understand how much time the whole MergeSort will take. So what is going on? A problem of size n becomes a problem of two problems of size n by 2, right? You are dividing into left half, right half. But unlike binary search, you cannot discard any half, right? In case of binary search, we can discard one half. But in case of MergeSort, you have to keep both half and solve each one of them, right? So a problem of size n will become two problems, each one of size n by 2. Similarly, n by 2 will become n by 4, n by 4, n by 4, n by 4. Similarly, n by 4 will become n by 8, n by 8, n by 8, n by 8. And finally, it will become a problem of size 1, right? Clear so far? Now, like binary search, let's assume after k steps, n this way, n will become, after one iteration, n becomes n by 2. After two iteration, n becomes n by 4. After three iteration, n becomes n by 2 to the power 3. Let's assume after k iteration, n becomes 1. So what will be the height of this tree? Or what is the value of k?
Log n.
Log n, right? Same as binary search. After one iteration, n becomes n by 2. After two iteration, n becomes n by 2. N becomes n by 2 square. After three iteration, n becomes n by 2 to the power 3. So let's assume after k iteration, n becomes 1. So n by 2 to the power k is 1. So we have already seen k equals to log n, like binary search. So height of the tree. So this height of the tree is log n. We are not done yet. Height of the tree is log n. Now every level, you are aware of level, right? Level of a tree. This is one level, level 0, level 1, level 2, level 3. every level there are some work going on, right? What is that work? Merging. In each level, you have solution of size n by 8, n by 8. You need to merge them. 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 Right? So every level you need to perform merging. And what is the time complexity for merging?
N.
N. So every level you need to perform n task. And total levels is height of the tree. That is log n. So total time is n multiplied by log n. That is n log n. Clear? Is it do you want is it clear to you how to derive the time complexity? So in the next slide, I think. Yeah, this is the slide. So n becomes 2 subproblems of size n by 2. Then it becomes 4 subproblems of size n by 4 up to this point when every subproblem has size 1. So what is the total height? Is log n. And you have understood, like binary search, how to calculate that height. Now each step we need to do merging. And how much time it takes? N. So in every level we need to perform n task. And total level number of levels you may expect, you may think it's similar to height of the tree. So number of levels is log n. So total time it will take n multiplied by log n. So the time complexity is n log n. Clear? Again, you may expect a couple of questions from here in your midterm as well as final exam. So, and this is called recursion tree. This is kind of tree, right? This is the root of the tree. This is the children, left child, right child. You will come to know more when you take data structure. This U4. When we talk about tree data structure, tree is a kind of data structure. We'll talk about that. So this is a tree, while this is the root, this is the children, left child, right child. So this is called recursion tree. So using this recursion tree, you can calculate or derive the time complexity. There are many other ways to do that. So is it clear to you so far? Okay. The other way is using recurrence relation. So what is the recurrence relation? Same logic. Tn is the total time to perform MergeSort. It is equals to you need to sort a problem of size n, you need to sort these subproblems, these 2 subproblems, right? To solve this one, you need to solve these 2 subproblems. Yes or no? To solve a problem of size n, you need to solve a problem, 2 subproblems of size n by 2. Then you will merge their solution. So Tn is the time taken to solve this problem, which is equals to, you need to solve 2 subproblems of size n by 2. You need to solve 2 subproblems of size n by 2. Plus, you need to merge their solution, right? So the recurrence relation is Tn equals to 2Tn by 2 plus order of n. Order of n for merging. This is for division, this is for merging. Every time the problem of size n will become 2 problem of size n by 2. Then 4 problems of size n by 4. Like that. So this is for division, this is for merging. So divide and conquer. So this is the recurrence relation. Now up to when you will divide. This is the base case of the recurrence relation. When, if your array is of size 1, you don't need to divide anything. So it's constant. Order of 1 means constant. That means it is already sorted. You don't need to do anything. So this is the recurrence relation of MergeSort. In your exam, you may expect question from this recurrence relation. Oh, we are out of time. So we'll continue our discussion from this point. Like only thing for binary search, I have mentioned Tn equals to Tn by 2 plus k. So that is to derive the recurrence relation. So we'll continue our discussion next day from this point. Yeah, I'm taking your attendance. Yeah, don't worry. I'm taking your attendance.